watching Highfinder has helped me a ton.
Thank you so much. Cool. This is getting better and better.
Yeah. I could do this all day with you.
Yeah. Hi guys, welcome to Texas. I'm with Total Hydrogen Solutions. They specialize in gas compression for hydrogen and many other things. And I'm here to see Greg. Let me see if I find him. Hi Greg, how are you?
Good.
Thanks for having us. So we're here to understand what you guys do, because I know hydrogen compression is super important, but you do even much more.
Oh yes.
What is this?
Well, this is a power backup plant that's all hybrid system, clean energy.
So you have your solar.
Yes. So we have solar in here. Ideally, really what's going to happen is there's a whole lot more on the roof of the customer, and then we have that coming into our system. So everything you see here is stuff that we've all integrated.
All right.
So you have the electrical panel, we have a battery system on the bottom.
Okay, this is all the electrical side.
Yep.
Okay.
So all the PLC work, electrical work.
Okay.
The panels over on this side. So with a hybrid system, so for this one, the customer wanted to have a battery system and a hydrogen fuel cell system.
All right.
So what we have here is coming from the solar or from the grid. We're charging up the batteries. These are flow batteries.
Down here, okay.
We've integrated all the thermal equipment and everything.
Oh, yeah, I can see more.
Yep.
Oh, yeah.
So this is actually still in construction.
Okay.
But we're going to add a few more banks of batteries here. And then on the other side, we'll go a hydrogen fuel cell as well.
Okay.
So batteries will take kind of the initial load, and then the fuel cell will provide the.
And they can charge a vehicle here,
yes,
or
sir.
what is this for?
Yep.
Oh, yeah.
So this is kind of a simple slow charger, but we could outfit a fast charger on here as well.
Oh yeah. Okay, so let's go into your workshop, because I know you have lots of details that you can show us there.
Great.
So let's go.
Sounds good.
Yes, Greg. So what exactly is a hydrogen compression system?
Yeah, so simplest terms, it's any system that's compressing hydrogen, taking it from a lower pressure, going to a higher pressure. Okay. We've got an example right here if you want to take a look.
So we can actually see how it works.
Yep. Yeah, so what we're doing here is we've got a source of hydrogen here. These are electrolyzers.
This is an electrolyzer system. Out. So the hydrogen comes out here.
Yep.
Okay.
And it comes out at low pressure, about 30 to 35 bar. It starts to build up in our buffer tank over here.
So that comes through there.
Yep.
Over here.
Yep.
And then here.
And then we bring that down into a compressor right here. So that's a pneumatic booster. And what that does is it's pushing back and forth when it's operating and going into a higher pressure tank over here. So we have two different tanks, two different pressures, our low pressure, and then our medium pressure.
So this one builds up what pressure?
So this will go, initially it goes to 350 bar.
Okay.
But it'll also go all the way up to 700 bar for refills.
Okay, so that will go in there. And what is this part here?
Yeah, so this is all the controls. So there's a lot of automation here as well. So set without, it can be set to go on its own, essentially, for quite a while. So it'll read the buffer pressure here. So once it gets up to 30 bar, the electrolyzers don't want too much back pressure.
Right.
So that's when we start compressing.
Okay.
And then once it gets below 10 bar, we don't want to starve the boosters or the compressors. Okay. So then we stop and let it build up pressure again.
Okay.
Yep.
So you're basically building up, you're keeping a nice pressure on the side of the electrolyzers, and then at the same time filling up your booster. When do you stop?
Yeah.
Do you at any time? I mean, when the tank is full, what happens then?
Yeah. So there's also automatic switches that would stop the compressor when it's too full to make sure we don't overpressurize.
All right.
So a lot of that's what's behind the panel. There's all sorts of gauges and switches that make sure that we don't go into any dangerous scenarios of
So you had the buffer, and you had the other one. At what pressure level is that other one working?
350 bar.
350 bar.
Yeah.
And this is what is this?
Yeah, so this is a system we built for our customer, H&O. Mm-hmm. So this is, they desired to have a compact hydrogen refueling station. So something that could be mobile, could be paired with 5, 10, 15 of the Naphtha electrolyzers, and have the opportunity to fill a Toyota Mirai to 700.
So that is what essentially does that come off?
Yep.
Come off?
Oh yeah.
Okay.
Yeah.
Oh yeah.
Yep.
So,
So this is a way nozzle. So what we do here, and actually if we had the vehicle, we would be receiving some feedback, so we would know what the pressure and the temperature of the car.
Of the cars.
Yep.
Okay, yeah, that's the infrared
Yes.
connections there that you can see here. Okay, so that goes right there. That's nice that you can actually see that, because you know, on the ones that you see on the highway normally you don't see the temperature. You know that's going on, but here you have it. Okay, so that feeds in there. And is it this same compressor that does the 700 bar for the vehicle as well?
Yes, sir. Yep.
Okay, so but you don't have a storage for those, so that goes straight.
Straight. Yep. So as we call it a top off or whatnot.
Right.
We could fill a even higher pressure tank and do a cascade fill. So we do a lot of systems where we do very high pressure. But for this simple kind of demonstration, we just wanted to settle with some simple steel tanks.
So okay, we started by saying what is a hydrogen compression system, and I mean everyone knows that this is a compressor, and those are tanks. But for what I understand now, what you do is the compression system.
Yes.
So you know, connecting it with all these things, so that in the end you get a nice pressure that you want out of your electrolyzer system, which is delivering at a certain pressure. All right. Okay. Maybe we can take it a little bit broader. I know that you do more applications. Can you take us a bit deeper into the whole subject? Yeah. So you said there's different scenarios. Obviously, we've seen the one refueling application, but when we talk hydrogen compression, do we see that anywhere else?
Yes. So a few different scenarios. So one for a large electrolyzer, so hydrogen production plant.
Yes.
And our main challenges with that is we're starting at very low pressures. We have high compression ratios. So compression ratio is just what it sounds like. A 10 to 1 would be 30 bar to 300 bar.
All right. Okay.
So that little tank of 30 bar,
if
you're hooking that up to a large electrolyzer, that's going to fill up very quickly. And the electrolyzers will get too much back pressure. So we have to kind of model out, you know, how big of a buffer storage do we want. We want to make sure that we're achieving the right flows. So enough hydrogen is going through these compressors.
Okay. So here we see the electrolyzer system, and that's the low pressure. And then you're basically managing these two compressors and managing the two tank systems to get the right pressure. So that's that. Okay.
Yeah, so any hydrogen generation plant, they're going to have some level of pressure that they want to store it at, sometimes multiple levels as well. And we can have compressors that, you know, compress to one pressure and at all times, or maybe multiple pressures. So there's a lot of controls that go into that.
Okay. So this is one scenario with the electrolyzer, which is similar to this?
Yes.
You have other ones?
Yeah. So a pretty common scenario too is just in a refueling scenario where people are having hydrogen being dropped off.
Yes.
So, you know, here's a little tube trailer
like
here.
a trailer coming in. Okay, right.
Or it can be in pods that are dropped off. We call it drop and swap. And the challenge with that is we can regulate the flow, but we have a pressure that's decreasing. Because as that tube trailer is getting lower and lower and dispensing, the pressure is dropping.
All right.
So we have to control to make sure that we can, usually what people want is speed. We want to make sure that we can fill up our tanks and do the amount of refilling that we need. So we have a changing variable of a pressure that's always dropping. So these compressors, as that inlet pressure is dropping over here, these compressors are moving the hydrogen slower and slower.
Okay.
And so we have to do some smart controls. When the trailer is very low, we might switch to being in series instead of in parallel.
All right.
So you think again, let's say it's, you know, all the way down to, you know, 50 bar. This might take it up to, you know, 300 bar, and then this will take it up to, you know, your 520 or something.
All right. Okay. So that means so all the piping is in place. You're just switching valves to get it into this.
So a lot of controls, and believe it or not, a lot of the controls, we have a lot that are electrically driven, but a lot of them are mechanical. Just seeing different pressures and making switches.
Okay, so they just react based on what pressure they see, and then they flip over. All right. And how fast are these? How fast would this scenario switch to that? Is it
milliseconds?
Milliseconds. We're talking. All right. Okay. That's interesting. And okay. Right. So and the compressors take that. They are happy to work with whatever.
So that's another thing that is important, and our role is making sure we're selecting the right compressor technology.
All right.
So different types of compressors inherently do better at starting and stopping and adjusting than others. Some don't like that, but there's other compressors that do really well at your very, very low pressure. But they want to be steady all the time. So sometimes we even deal with hybrid technology. So we'll have two totally different types of compressors.
So I know you're an expert at this. So maybe just a very quick one. So if you, what would be a combination? You have the, like a hybrid one. What two types of compressors would you combine, and why would you do that?
Yeah, so we would combine a diaphragm compressor.
Yes,
we have a very low inlet, very steady flow. Because if we can be predictable, and it's not a system that's turning on or turning off, it's a grid-connected electrolyzer or another steady flow of hydrogen, that'll be great for getting to our initial storage pressure.
Okay, all right.
And then we would top that off with a booster, something that needs to turn on, turn off when a vehicle kind of comes in.
And what kind of compressor would that booster be?
Yeah, so that's just a boost compression system.
Okay, with the pistons.
Okay,
the piston type.
Yeah,
okay, all right.
Pneumatically driven or hydraulically driven, like you saw earlier.
Okay, cool. What other applications is it? Oh, that's all.
Yeah, so there's one more. So this is a really good for a boost compressor.
Yeah.
So this is kind of a breakdown of a refueling scenario. So if for this scenario we've got 3 pressure banks.
All right.
After refueling, you have low pressure. Now your medium pressure is relatively low, and your high pressure you have a little bit less of.
So different tanks.
Yep.
Tank system that are there. Okay.
Different tanks. So. So what a compressor can do is consolidate that, so now you have your higher pressures and you can do more of a full refilling after the fact.
All right.
So taking your volumes and consolidating them into the pressures you need, so you can do a full fill later on.
Okay, so then it's all in order again, basically. So basically you're moving stuff from one tank to the other. Almost. Okay, Actually, that is a whole big topic, and I need to say we did a video on that one as well.
I learned a lot from that.
I did. It's very interesting. It's actually it's like organ pipes. Have different types of valves and how they do that. So it's nice to see all these applications. I know you guys put them in action. Maybe we can still see some more on your hardware. Outside.
Absolutely.
Let's go take a look then.
Yeah, great. Okay. Sounds good.
Yeah. So, Greg, what do we have here?
Yes. So this is another compression system that we're building.
Okay.
So that's why you see there's not a whole lot of piping yet.
There's 2 compressors here.
2 compressors. So these are hydraulically driven.
Hydraulic compressors.
We have the smaller ones that are driven by air. This is driven by a hydraulic fluid.
Yeah.
So you can move a whole lot more gas.
Yes.
And you can still achieve the high pressures as well.
Okay.
So this is actually going to, our partner H&O is building a megawatt electrolyzer plant. So this will move 500 kilograms a day.
Wow.
So,
okay. These 2?
These 2.
Okay.
Yep.
So you gotta, probably this is the initial stages here.
Yes.
Yeah. So there's going to be a lot more around there.
Yes.
And then, so this is the gas compression side. Is there more?
Yes.
Around?
So this will be gas compression. We'll have a heat exchanger that we build here as well.
Yeah.
We have chillers that live outside that will keep that hydrogen so it's doesn't overheat. And then on this other side is our non-class rated side. Okay. So this is where we have our electrical components, our panel, the electric motor, and then the hydraulic pump that's actually moving the fluid.
So this is an example of a bigger application, so megawatt.
Yep. So it's a custom container that we designed and built.
Yeah.
And so we have vent stacks that that are going up.
Come
We've
through
got
there.
one currently.
I can see that. Yeah.
So a lot of work goes into a big metal box for hydrogen.
I don't know if you noticed, but how heavy is this going to be at the end?
Oh, I think it'll be about 10,000 pounds.
10,000 pounds.
Yeah.
Okay, I gotta do the math now for the
4,000 kilograms, I think.
4 tons. Okay.
I think so.
Okay.
4,000 kilograms. I don't know. I'm better at my bar and PSI conversions.
Well, we are in Texas. Nice. Okay. Cool. This is getting better and better.
I could do this all day with you.
So Greg, is there something special in this scenario?
Yes. So it came to me that this is essentially kind of like shifting gears in a vehicle. So as your pressure is dropping, this gear might work initially, but once that tube trailer gets very, very low, you're going to need to shift gears and work with a compressor that can work for that pressure and still maintain good, steady flows, so you're not waiting forever to fill up.
All right. Okay. So you can even put them after each other, and that works well.
Yes. Yeah. Yep. So what it's doing is it's taking that lower pressure, feeding it into here, and there's, of course, this is a simple arrow. There's a whole lot of things involved.
Exactly. There's more pipe inside.
But then that goes into that next compressor, so it can, pressurize it up into that next higher pressure. And when we're talking about hybrid systems, this is where a scenario that we might use a hybrid system. So similar to what we showed earlier of having two compressors in series, we might have one that doesn't want to do start or stop, but we can just have that going for quite a while, and then boost into a much higher pressure.
Okay, great. I wanted to ask you about the safety of all of this, because I know that that's a big topic often. And I know that things are actually safe, but can you tell us about some of the challenges and how you guys make that happen?
So one of the great things that I love, our company is a division of pneumatic and hydraulic, and we've been compressing gases for 65 years.
Right.
So my challenge of being relatively new to this company is I always say high pressure is 700 bar, 1,000 bar.
Okay.
To them, that's medium low pressure. So they've been doing pressurized gas systems far, far higher for quite a while. So
what kind of pressures has they been doing?
75,000 psi.
All right. And these are oil and gas applications?
A lot of oil and gas, some aerospace, and a lot of testing systems. So if someone wants to pressure test a tank or
so they've made that safe, so getting this lower levels, as you would call them, safe is not a problem.
And of course, hydrogen has different properties that we need to pay attention to. We do a majority of our work early on has always been to study out all the different safety considerations, the different certifications and everything with that. Another thing that I really like is a lot of our systems, there's a lot of mechanical drivers in that, so a lot of backup systems, so it's not all maintained by a computer. And if there's an issue with that, there's a lot of inherent safety in the design.
So backup, okay. So I don't know, is there so if I want to make a hydrogen compression system safe, are there 3 things I need to do or something like that?
I think selecting the right components.
So components is one,
because even in a simple system like that, there's about 300 little bits and pieces.
Okay, all right.
So those are different failure points. So selecting the right components is really big. Making sure that you are the actual build out by people who are experienced and know how to properly cut tube and connect and everything with that. That was a challenge that I've run into before. We had people who were fantastic with hydrogen, great experience, but they didn't know how to bend tube and pipe and proper fittings. So sometimes it's working on that outside the hydrogen industry experience, people who are just experienced in high pressure gases. And I think the third thing would be to make sure that you have multiple points of backup. People talk about multiple points of failure, but you also want to have multiple points of backup. So if this valve fails or if this system fails, you have another backup system that can prevent something to be catastrophic.
So when you look at a system like this, what would be the backup that you would put here?
Yeah, so a lot of that's what's behind it.
Okay, what we don't see.
And you're welcome to see, and it's a pretty tight.
Maybe we can take a sneak peek. So it's right in there.
Yep.
So we got the basic gist of it, that it's coming in at lower pressure, but what would the backup system do? Would this open the valves, or would it let it out? Or do you have an emergency
We have
outlet?
some vents too, so actually I can vent some right now, so you can see that pressure is dropping right now.
All right, okay.
So venting systems.
So this is now it's taking out the hydrogen that's in the system.
Outside. Yep.
All right. Okay.
Yep.
That is to your piping, which you have outside the building. All right. Okay. So
we don't do any hydrogen venting indoors.
Okay. Good idea.
But again, this is still a prototype, kind of more of a proof of concept. So there's some things in here that we can have a bit more flexibility with. But a lot of times it's in isolating different parts of the system and making sure you always have proper venting.
Okay. So I guess that's another safety consideration there, And this was pretty mechanical.
Yep.
So if the electricity goes down on this, what happens?
Yeah, so that's another thing where it's good to have your mechanical systems.
Yeah.
And then we have a mixture of solenoid valves that are, if they are electrically, so solenoid valves would be electrically controlled. We have a normally open valve, so if power goes off, then it's always going to be safe to vent.
So Greg, I guess this is a good point. We're seeing a vehicle application here, but maybe can you tell us a little bit of where you see this going in the future also? You know, more and more, I know your company has done some, let me say, non-hydrogen work, but it's going in there. So how do you see the future coming through?
Yeah, so I'm really excited because I'm seeing a whole bunch of interest on different types of hydrogen production, different people really jumping into producing better electrolyzers and systems, and also people looking at the consumption side as well. So our job, we always call ourselves just fancy plumbers and electricians. We just want to enable the hydrogen economy and different companies to realize their products by properly doing system integration for them.
Okay, so you guys are getting better at what you're doing. Just, I know this is a pretty rough question, but like, if you say in a hydrogen compression system, obviously the compressor is going to cost you, I would say, a considerable amount. Maybe the storage also going to cost you, and then, well, if you are adding the production, but that's one side. But like, let's say the compression part, what does, aside from the compressor, what's the biggest cost driver there? And what does it cost to integrate?
Yeah. So it's interesting because you touched on some good points that I always like to come in early on in conversations with customers that are trying to build out a system, because they might have in mind, here's the compression, this is how much flow we need, or this is how much storage we need. But if we can come in early enough and give some good input, because sometimes it's a different play. So for example, if you wanted to achieve certain flow rates, you could do that by stacking a whole bunch of compressors. However, you could also achieve that by having a bunch of storage. So sometimes it makes more sense to add a little bit more storage or a little bit more compression. And so it's helpful for us, since we know the costs of all of that and kind of the trade-offs that you're doing, to really understand at the end of the day, what's the goal? Because people will say, I want 3.6 kilograms a minute. But really what they want is they want to fill 5 trucks at 350 bar in a relatively short period of time. And so oftentimes I would say the most expensive things are when people don't take that kind of integrative approach and but just try to look at things in a little box. Because then they size a compressor for this rate and they size the storage for this rate, when really they might be over-engineering or oversizing everything.
Well, thank you, Greg. Honestly, you've shown very nicely how important this part is. And I think it's also great that we did a video just on the compression system, because that's super important, also cost driving factor on this. And the better we get at this, the more we have people like you doing this, also considering all the other ramifications around that, the better the cost situation will be, and the easier this technology will scale. So thank you very much, Greg.
Thank you.
It was absolutely fascinating.
I'm not paid to say this, but I do say that because I have to learn so many things.
No worries.
Watching Highfinder has helped me a ton.
Thank you so much. Thank you, Jeff. Well, thank you for watching, and we hope you enjoyed it. If yes, give us a like. Or go on highfinder.com. You can find components like these. You can meet people like Greg. You can see also these things that you need to build these systems together. So compressors as well. Give us a like. Go on Highfinder. Thanks for watching.